Okay, so this next video is going to be talking about significant latitudes and the amount of sunlight they get. This will generally cover questions number 12, 14, 15, 13, 14, 15, 16, 17, 18, 19, and 19. So we're going to stop at 19 there. So it deals with this picture right here, and it deals with latitude. Remember latitude, you probably learned this back in elementary school. Latitude. Longitudes are the lines that go from north to south. They tell you how far east and west you are. Latitude lines are the lines that run east and west, and they tell you how far north and south you are. Simply put, it's like the inside of a circle. If you start at the center of the earth and point straight out, that's going to be 0 degrees. That is the equator. So 0 degrees latitude is the equator. And then this would be a 1 degree angle, 2 degree angle, 3 degree angle, all the way up to 90 degrees. So the center of the earth pointing out 0 degrees right there, just like your protractor. If this was the center of the earth right here, the equator would be at 0 degrees. The North Pole would be looking up at 90 degrees. Now the sun is over there. So if the sun is over there, that means if you are standing on the equator, you would be looking straight up at the sun. However, that's if the sun was over there. Turns out that because of something that happened on early on in the formation of the Earth got tilted. And this is an important number. It got tilted at a 23.5 degree angle to the sun, to the plane of the sun. As we go around the sun, the earth is pointing at a 23.5 degree angle, which means that sometimes if the sun's on this side of the earth, that means the sun is not shining directly on the equator. In fact, it's shining 23.5 degrees north latitude. So in order for the sun to be shining you directly above head, you would have to go to 23.5 degrees north latitude, and that would be called the Tropic of Cancer. If you were at the equator on this day, you would actually have to look north to see the sun at its highest position. Here in the Pacific Northwest, we're always having to look south to see it because the sun's never directly overhead because we're 47 degrees north latitude. At the North Pole, notice at the North Pole, you have to look down, but it's not on the horizon. Now, as the Earth goes around the sun, I'll make this picture bigger so you guys can see what I'm talking about. As the Earth goes around the sun, and now this is the other time of the year where the sun is directly above 23.5 degrees south latitude. At this point, if you're at the North Pole and you're looking straight up, you're looking down, there's your horizon. You can't even see the sun because the sun is coming from that direction. So that means if you're at the North Pole at this time of year, you get no sunlight. At the South Pole, it doesn't matter what time of day it is, you're always getting sunlight. Okay? In fact, above this line, which is 66.5 degrees north latitude, anything north of that on this day is full nighttime. That's called the Arctic Circle. And 66.5 degrees south latitude, they're getting 24 hours of sunlight. That is the Antarctic Circle. I have been to Iceland, which is above the Arctic Circle in the summer. It's really weird. The sun never goes down. So this, since the northern latitudes are such a low angle to the sun, which means low intensity, that means that those times are getting less sunlight, less intense sunlight this time of year. And the southern hemisphere is getting more. So this would be what we would call winter, but in the southern hemisphere, they would call that summer. This particular day, when the sun's directly above the pole, I'm sorry, the Tropic of Capricorn, when the sun's directly above the Tropic of Capricorn, 23.5 degrees south, that means it's that's one day a year. We call that We call that the winter solstice. Australia would call that the summer solstice. Okay? Go around to the other side when the sun's this way and the sun's directly above the Tropic of Cancer. We call that the first day of summer, or the summer solstice. And that's where, if you're at the North Pole, you're getting 24 hours of daylight. That's for us. We get 24 hours of, we don't get 24 hours of daylight, but in the summer, days are longer because the sun is shining. If you look at the globe, if the sun is shining, this entire part of the earth, let me just hold it like this entire part of the earth, everything on this side is lit up. Okay? And as you rotate the globe, you'll notice that as you travel around, they're getting a lot more light. This is called the circle of illumination, the difference between day and night. In the wintertime, we are traveling through more sunlight. In the summertime, I'm sorry, in the wintertime, let's see, I said that backwards. In the summertime, we're getting a lot more light. In the wintertime, the time we're right now, we're facing away from the sun, so the circle of illumination is working against us. We travel through very little daylight and a whole bunch of night. So that would be the first day of summer and the first day of spring. So when is the Earth, when is the sun directly above the equator? Well, that happens 2 times a year. When the sun, as the Earth goes around the sun, if the sun's right here, now it's shining directly on the equator like that. So even though the Earth is tilted, the sun is directly on the equator. And what that means is that if that circle of illumination goes through the north and south poles, we're going to get everybody in the globe 12 hours of day and 12 hours of night. So everybody gets the same amount of night. Everybody gets an equal amount of night. Hence why we call this the first day of spring and the first day of fall. The first day of spring and the first day of fall is called the vernal equinox. Nox means night. Equinight. Everybody gets the same. On the first day of spring and the first day of fall, they get equal day and night. All right, that's only one day a year that happens, that everybody gets 12 hours of daylight and 12 hours of night. And if you're at the North Pole and you're going from summer to winter, the sun is going to set that one day and not come back up for 6 more months when we have the fall equinox, spring equinox, excuse me. Okay, so when you guys are doing this part on the lab, and I just realized I did this with mask on, that had to be awkward. When you guys are doing this part of the lab, you guys are going to show me where the latitudes are. Somewhere in here, use one of these globes, label the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle, the Antarctic Circle, the circle of illumination. That basically is this line that separates the light from the dark. And tell me what the tilt is, 23.5. Remember that, we use that a lot, 23.5. That's the angle of the Earth. So you're going to label that, and you're going to have to label that on the paper, not on your lab. There's not a way of labeling a lab, so you're going to have to put that all on this paper. You're also going to have to look up and tell me what are the dates of the first day of winter, the first day of summer, the first day of spring, the first day of fall. So the autumnal equinox, the vernal equinox, the summer solstice, and the winter solstice. So that's what you're doing for those questions right there. And I'm not going to go through each one of these questions. Remember, if you have something that's, if you have something like question number 21, it's in parentheses. That means you're choosing one of these 3 choices, and you're going to highlight it and click the highlighter tool and tell me what the answer is. All right, same thing with question number 9. So work on those. Remember, if you have questions in class, you can certainly raise your hands and ask.